Fine. Okay. Used to being bossed around is what it is. Okay. Go ahead. Carmen, shoot.
I think I'm just spacing, but it is y equals 2x squared minus 2x minus 48, and it is just right in standard form.
Oh, okay. Okay, there's two ways that this can be done. The method that I think most instructors would use is complete the square, CTS. However, I find that kind of a waste of time because we already have a formula. The vertex is negative b over 2a comma something, right? Remember that? Okay.
Really quick, it's minus 20x. Sorry.
20x. Okay. That will make a difference. Plus 48 or minus 48?
Minus 48.
Okay. All right. So we know what the vertex, we know how to start finding the vertex. When it's in this form, we know that this is how we find the vertex. So we have 20 over 2 times 2 comma something. So that's 20 over 4. That's 5 comma, what's that? 50, negative 50, negative 98.
Sorry, how did you just get that number?
Which one?
The negative 98. Because I'm reading my notes and I'm seeing that number and I'm like, what did Larry mean by that number?
Okay. Okay. Back up here. When I said the vertex, the way I first introduced it was negative b over 2a comma plug it in. Okay. So we took negative b over 2a, 20 over 4 is 5. Then I plugged the 5 into the original problem in place of x. Now, the way I got the 98 was doing a whole lot of math in my head real quick, but that's why I trust you guys to check me. So if x is 5, this is 25, this is 50. If x is 5, this is minus 100, so that's negative 50. Minus 48 is negative 98. That's what I was doing in my head to get that 98. I basically plugged it in. Okay, I have everybody with me? Okay, so now I can go immediately to that standard form, y equals 2 times x minus 5 squared minus 98. Okay, like I said, Carmen, most instructors would say, oh, you have to use this fancy complete the square crap stuff, math, whatever. Okay, and I'm just going, I've never understood why, when you have this formula and we have to use it sometimes, so why not use it this time? Find the vertex, put it into this form. That's it, you're done.
Okay, I'm starting to remember that. Thank you.
Okay. Anybody else? Anyone?
I have another one. Oh, sorry, go ahead.
Can we do number 19? I mean, sorry, 18 on the study sheet? Do you want me to just read it to you?
Is it the right triangle with a hypotenuse of 7?
No.
Okay, okay, which one am I doing? Yeah, just read it. It's easier.
Okay. It's 5y.
Okay, this is, you said 19. Okay, 5y.
It's number 18, but
18. Okay.
yes. So it's 5y squared minus x squared equals 1. And then it's xy equals 2.
Okay. Trying to decide which is the easiest way. Okay. I would take this equation and get y equals 2 over x. Okay. And then plug it in here for y. So I take this equation, get y alone. You could have gotten x alone. Maybe getting x alone would be easier, because then you don't have to screw around with the 5 anymore. So do you want to get y alone, or do you want to get x alone? That'll be your choice. It won't matter.
I did it with the y equals 2 over x.
All right, we'll do that and
But
we'll
I
see
got-
what happens.
Yeah, I got stuck, so I didn't
Okay,
know how to
okay.
fix it.
So then we have 5 times 2 over x quantity squared minus x squared equals 1. Yes or no? So
Yes.
this would be 5 times 4 over x squared minus x squared equals 1.
Yes.
Okay. So where's my glare? I can go down one more. So this is 20 over x squared minus x squared equals 1. All right. Now is where the magic happens. We need to clear fractions. We need to get rid of all of the fractions. Okay. So I'm going to multiply by, where's my glare? It's right here. Okay. I'm going to multiply by x squared and distribute. Remember, we did this way back in, I think, it was chapter 9, where we had, well, you'll see. So when I distribute it here, that's going to give me 20, because the x squareds will cancel, minus x to the 4th equals x squared. And I'm in the glare, aren't I? 20 minus x to the 4th equals x squared. Is that better? Yeah, you can see that. Are you with me?
Yes.
Okay, so now it's a power equation. I'm going to waste a step. Negative x squared, x to the 4th minus x squared plus 20 equals 0. Remember, x to the 4th, dummy. Highest power first. I'm going to multiply everybody by -1. So I have positive x to the 4th plus x squared minus 20 equals 0. So first thing I did was I got this thing equaling 0, and at the same time I got my highest power in front. But then I said, oh, Foster's got that funny thing. He doesn't like his highest powers to have a negative coefficient. So he multiplies everybody by -1. That flips all their signs. Okay?
Yes.
All right. So then we're going to factor this and get x squared. Oh, well, actually, let me wait. I can do that in my head. I'm not sure you guys can. Remember when we did substitution, we said let u equal x squared. Okay.
Yes.
We talked back in chapter 9. We said, okay, this kind of looks like a quadratic equation, except it's power of 4. So I'm going to pretend that it's quadratic by doing a quickie substitution. So my problem becomes u squared plus u minus 20 equals 0. 20. Okay. Personally, I take a shortcut, but I don't want to take that with everybody watching, because I didn't teach that shortcut. So this factors as u plus 5 u minus 4 equals 0. Can we still see? Yeah. So u equals -5 or u equals 4. Okay. Coming back over to here. But u was worth x squared. So we have x squared equals -5 or x squared equals 4. Okay. We're solving the system. We're going to reject the negative, the imaginary. This will be imaginary. This will be x equals plus or minus the square root of -5, which will be plus or minus I radical 5. Because this is actually a graphing problem, where do the graphs intersect? We can't have an imaginary intersection. So this is rejected, and you could have rejected it up here at this step. You could have said in this case, x squared can't be negative, reject it. But I wanted to show you why, because you're going to get that I in there and you still reject it. Here you square root both sides, and you get x is plus or minus 2. All right, are you with me so far?
Yes.
This is a cool question. So now, wait a minute. Remember how I separated this? I said if x is 2, then let's put it here. We have 2 times y equals 2. That's y is 1. So we have 2 comma 1. Okay, but if x is -2, okay, because we have 2 x's that we're going to plug into that one. And the only reason I'm plugging into that one is it seems the simplest one to plug into. I always choose the simplest, easiest thing to plug into. Okay. So if I plug it into that, I have -2 times y equals 2, which means y equals -1. So here we have if x is -2, y is -1. Okay, so these are my solution set. These are the 2 answers. And I would say that's the end of it. Is that okay or not? Okay.
Yes. I just got stuck where you made it very easy with the x squared times everything.
Oh, cleared the fractions?
Yeah.
Yeah.
I got stuck there, and after that, I didn't know what to do. But
okay.
after
Basically,
that,
that write yourself a note then for the test and for the future. Anytime you have a problem with fractions, get rid of the fractions, clear them. Okay. There may be an easier way to do a particular problem. One problem might have a really super shortcut, woohoo! But in general, it's safest just to clear the fractions. Okay.
Sorry, how exactly did you clear the fractions? I don't really understand that part.
Okay. Do you understand how I got to this step in black?
Yes.
Okay. Then the LCD is the lowest common denominator. So what I did was I distributed the LCD to here, and it canceled the x squared. So I got 20. But I have to distribute the LCD to every term. The LCD distributes here. That's how I got x to the 4th. And LCD distributes here. That's how I got x squared. So my goal was to somehow cancel out this denominator. And the fact that it screwed up everything else isn't my problem right now. I wanted to get rid of the denominator. So I distributed this LCD to everybody.
Okay, I understand now.
Okay.
Thank you.
Yeah. But Carmen, you had another question also.
I don't remember now.
Okay. No problem. It'll come back to you. We have time. Anybody else? Any other questions on anything?
Hi, Professor, just the captioning for me, please.
Okay, we'll get you. Sandra. And I will turn off.
Thank you.
You're welcome.
Thank you.
Okay, we got everybody. All right. And Marissa, I got your extra time on there. It's set for you tomorrow.
I'm sorry?
The extra time, the whatever for the test.
Oh, thank you so much. Okay, I
Yep.
didn't hear that. Okay, great. Thanks.
I'm sorry.
All
Yeah.
right.
Anyone else? Any other questions?
Can I ask another question?
Of course.
So same worksheet, number 15, it asks what kind of problem it is. And I thought it was an ellipse, but it says it's a circle and I'm not sure why.
Oh, okay. All right. Can I erase all this? Anybody still taking notes on this one? Remember, I am recording this. Okay, I'm gonna erase this.
Did you update the practice worksheet or something on Canvas? For
Yeah,
2D?
remember Anne found 3 errors. Okay, on the practice worksheet 2B, 10B, 10C. I'll give you those answers, but I updated the worksheet. You don't have to run them off. You just might want to look at them and scribble out the answers you had and put the correct answers on.
Awesome.
Okay.
Thanks.
But yeah, for those of you who weren't here last night, Anne found a few errors on the practice worksheet for problem number 2B, 10B, 10C. She told me I figured out the right answers. Okay. And I corrected them on the worksheet online on Canvas. Okay. And you could just check that and then write them over whatever you did. All right. Where were we? Which problem?
15?
15. Go ahead. Read it.
It's 6x squared
Uh-huh.
equals 16 minus 6y squared.
Okay. So all right. If we call this 6x squared plus 6y squared equals 16, shoot. Okay. The question is it an ellipse or is it a circle? And I realized that I talked really fast when I was doing this. I said for a circle, okay, you have an x squared, you have a y squared, and you have a plus x squared and a plus y squared. And I said the coefficients have to be the same. Usually they're 1. Yeah, it's hard to read. Okay, that's just, okay. I said that. I know I didn't write it, but I know I said it. So for a circle, okay, the coefficients have to be the same, usually 1. For an ellipse, okay, you have an x squared, you have a y squared. They're both plus, but the coefficients have to be different. Okay, 3 and 5 or something like that. They have to be different. So let's look at this a slightly different way. Okay. What if we divided everybody by 6? Then this would be x squared plus y squared equals 16 over 6. That's definitely a circle. got a weird radius, but that's not what the problem said. It just said, is it a circle or an ellipse? So that's definitely a circle. Okay. If you took this and did it a different way, if you said, oh, I think it's an ellipse, so I'm going to divide everybody by 16. Okay, well, then you have 6 over 16 x squared plus 6 over 16 y squared equals 1, because we know ellipses are supposed to equal 1. Okay, but wait, the coefficients are the same, but to be an ellipse, the coefficients have to be different. So by looking at this two different ways, it's got to be an ellipse. Is that okay, or is that double talk?
Yes, that makes sense. I must
Oh.
have missed where the coefficients can equal each other to be a circle. I thought that they always had to equal 1.
No, usually they equal 1, but they don't have to be as long as they're the same.
Okay, thank you.
Okay, okay. Maybe don't write this down. Okay, everybody, just kind of watch this. We know that an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. That's the equation of ellipse. And this a and this b number tell us how much we go in the x or y direction, how much is the x stretched out or is the y stretched out. That's how we get that weird ellipse. I taught you that a circle was x minus h squared plus y minus k squared equals r squared. That's the standard form for a circle. But, okay, some instructors are suggesting, what if you divided everybody by r squared? Then you get, where's my glare? Okay, then you get x minus h squared over r squared plus y minus k squared over r squared equals 1. Now, study this for a second. This is an ellipse. This is a modified circle. The only difference between an ellipse and a circle, if you do this, is check it out. In a circle, the radius is always the same. The x radius is the same as the y radius. But in an ellipse, the x radius is different than the y radius. Okay, so that is a different way of looking at this. If you divided everybody by 16, okay, you would have something over the one number, something else over the same number equaling 1. And because the two radiuses are the same, it's a circle. If the two radiuses were different, it's an ellipse. Okay, again, that's a different way that people are teaching these formulas. I avoided that, showing you that one, because you got enough problems remembering formulas. But anyway, bottom answer is the coefficients of a circle have to be the same. Usually they're 1, but they have to be the same. Okay, a lot of talk, a lot of BS. Anybody else? Questions? We can just keep doing this.
I think I might have missed something.
Okay, what?
So I was looking over the practice exam on question number 1,
Yeah,
and I was doing C, like when the rocket hits the ground.
okay.
And when I plugged it into the quad formula, I got a different answer than the one on the back.
Well, let's see. Anne didn't tell me I was wrong, so we'll see what happens. Did I copy it wrong? I don't think so. All right, we'll try it.
Oh, I see. Okay. I think I realized what I did.
Okay.
Why do you have to move it to the other side? Because it's 0
okay.
equals negative 9t squared plus 126t plus 700.
Yeah, my idiosyncrasy, okay, which remember the root word of idiosyncrasy is idiot, okay? Okay, let's start the problem. This is number one. You've got h of t equals negative 9t squared plus 126t plus 700. When it hits the ground, that says h is worth 0. So we have 0 equals negative 9t squared plus 126t plus 700. Okay, then I took the extra step of moving this to the other side. 9t squared minus 126t minus 700 equals 0. Okay, why? Because I've found over the years that students make less mistakes plugging these numbers into the quadratic formula or factoring with these numbers when the a value is positive. Students make fewer mistakes when they take the extra step to make the a value, a x squared, bxc, that kind of crud, a positive number. You don't have to, but I keep doing that because I'm trying to reinforce students tend to make fewer mistakes when they do that. That's
Can you
all I
get
did.
the same answer though?
Yeah, you will. You assuming
Okay.
you don't make any arithmetic mistakes, yes. But it's arithmetic and PEMDAS that generally kills students.
Okay. When plugging this into the quad formula, wouldn't b equal negative 126?
Yep.
And isn't the beginning of the quad formula negative b, so it would be a positive 126?
Yep. But it'll all work out. If you did yours, okay, you'd have 2 times negative 9 on the bottom, so you'd have negative 18 on the bottom. If you did mine, I'd have 2 times 9, okay, so I'd have positive 18. But you would have negative 126. I would have positive 126. So in the end, the negative divided by negative will cancel each other out and make a positive the same way I have a positive here.
The one you have written, the answer key has a negative 126, but then a positive 9.
Uh-oh. Uh-oh. That's right, but the quad formula is wrong. Ah, crap.
Okay, good. So I'm not tripping.
No, well, I can't answer that, but you're not wrong. I thought I checked that. Turn it on. Quit. Second.
I think it gives us negative 1141.
No, she's on part C. When does it hit the ground?
Oh, when it hits, okay, I did the wrong.
No, it's okay. I mean, we're bouncing all around. So if I go 9 and negative 126 and negative 700, solve. Oh, no. Okay. My answer is right. My work is wrong because I cheated. Okay. I plugged in this formula into my calculator and I got the right answers. But when I did my next step, when I tried to show you my work, okay, you are 100% right. That should be positive 126 as I use the quad formula. So my answers are right. My steps are wrong. Okay, because I basically cheated and used my calculator, the quadratic formula solver on my calculator. Okay. So, Lindsay, are you okay with that, or?
Oh, yeah, that's fine. I think I probably plugged something wrong into my calculator too, because I got a different answer, but now I'm getting the right answer.
Okay. So what's that? Two wrongs don't make a right, or two wrongs make a right, or two rights make an airplane?
We have the right to make a left.
Two rights make a left? Yeah, okay. Okay.
Thank you.
There's a joke I've heard in there too, but I won't repeat it. But okay, other questions? Okay, while you guys are thinking about another question, I want you to draw a 30, 60, 90 triangle, and I want you to show all angles. Okay, so put the 30, 60, 90 in. I want you to pick any number for the hypotenuse. Okay, I suggest you pick an even number, but you don't have to. Okay, pick any number you want for the hypotenuse and find the other two legs. Okay, so I want you to draw a 30, 60, 90 triangle, pick any number you want in the universe. I don't care. Put it on the hypotenuse and then figure out the other two legs according to our formulas for 30, 60, 90s. I'll pause and wait for a moment.
On purpose.
Yeah. Well, it won't drive me nuts, but it'll drive your trig teacher nuts. Okay, so I made a 30, 60, 90 triangle. I'm going to arbitrarily choose, I don't know, I'm going to choose this as 40. The hypotenuse is going to be 40. Okay. Then for me, remember the 40 is 2A and the side opposite the 30 degrees is A, half of that. So this has to be 20. If my hypotenuse was 40, then this has to be 20, and this becomes 20 times the square root of 3. Now, because everybody did this differently, okay, you're going to have all different answers. But here's the next thing I want you to do. I want you to divide all legs, or all sides, I should say, by the hypotenuse. Okay, I'll show you what I mean. On mine, I have 40, 20, 2 radical 3. Okay, I want to divide each one of those by whatever my hypotenuse is. 20 radical 3. Okay, so everybody would be doing the different division because everybody's hypotenuse was a little bit different. So this is going to become 1. This is going to be a half. And this is going to be the square root of 3 over 2. Everybody should have gotten that. That's kind of bizarre that everybody could have a different hypotenuse. But when we divide all your answers, all your legs by that hypotenuse, okay, we all get the same answer. What that means from a mathematical point of view is that all 30, 60, 90 triangles are in the same proportion. They're all shaped exactly the same. Some are bigger, some are smaller, but they're all in the same proportion. Okay? Hang on, we'll come back to that in a minute. Did everybody get this when you divided by your hypotenuse? Did you get the hypotenuse is 1, the side opposite the 30-degree angle was a half, and the side opposite the 60-degree angle was the square root of 3 over 2? Did everybody get that one? Yes, no?
Yes.
Okay,
Yes.
cool. Now, I'm going to have to erase that. Set that aside, but do this again for a 45, 45, 90. Whoops, 45, 45, 90 triangle. So do it again. Okay, again, any number for the hypotenuse, find the other 2 legs. Once you've done that, divide everybody by your hypotenuse, whatever that was. Okay. Again, everybody could have picked a different hypotenuse, but remember the hypotenuse, it represents a times the square root of 2. So if you set a times the square root of 2 equal to 60, where's my glare? Okay. And then divide both sides by the square root of 2 and simplify it, you get that. Okay. And again, everybody gets a different answer until we divide, each one of you divides by whatever your hypotenuse was. Okay. And then all of a sudden we get this 1 square root of 2 over 2, square root of 2 over 2. And unless you made a mistake up here, everybody should have gotten that. And what that says is that all 45, 45, 90 triangles are of the also same proportion. Some are bigger, some are smaller. This is way big. This is a hypotenuse of 60. This is a hypotenuse of 1. But they're the perfect replica of each other. They're in proportion with each other. Okay, if you could expand this perfectly, all sides the same, it would become this. Or if you could take this and shrink it down, it would become this. Okay, now I'm leading to something. Okay, any questions before I show you how all this kind of fits together, what I'm trying to lead you to? Any questions about any of my arithmetic up here? No, okay. Now, on the practice sheet, I talked about something called the unit circle. The unit circle. I said it's at the origin and its radius is 1. Okay. Well, that means its equation is x minus 0 squared plus y minus 0 squared equals 1, because the origin means 0, 0. That's its center. Okay. Only we clean this up and we just call that x squared because we know we don't need the extra 0 there, plus y squared equals, 1 squared. Okay. This is what everybody will call the unit circle. Now, they sometimes leave the power off of the 1 because 1 squared and 1 are the same thing. Who's they? Anybody teaching trigonometry. When those of you who are ultimately going to take Math 104, whether you're going to take it in the summer or whether you're going to take it into fall or eventually take trigonometry, Math 104. Okay, they'll start with some things and they'll try and scare you with some other crud, but the basis of probably the first 40% of everything you're going to learn in Math 104 is based on this unit circle equation. Okay, everything is going to come from here. Well, let's look at it for a second. A unit circle. It's at 0, 0. So this is the ordered pair 1, 0, because the radius is 1. This is 0, 1. Again, the radius is 1. This is -1, 0. The radius is 1 backwards. And this is 0, -1. This is the equation of the unit circle. This is the picture of the unit circle. And again, trig, yeah, after they do a couple weird things that scare you, whatever like that, and everybody goes, oh, I'm going to drop. Don't drop. Okay, don't panic. Then they're going to introduce this thing called the unit circle. Okay, and then they're going to do something really weird. They're going to take those triangles that I just erased, and they're going to put them on the unit circle. For example, if this was a 45, 45, 90, if they're going to draw that triangle right on the unit circle, then we know its hypotenuse is 1 because the unit circle says, oh, look, the radius is 1. And we know, because we just did the math, that this side is the square root of 2 over 2, and this side is the square root of 2 over 2, because we just did the math. So what they're going to do, and they're going to do it quite quickly, okay, is they're going to say, well, here's the unit circle, and you studied this in Math 96, and then we're going to put triangles on top of it, and poof, here's our answer, okay? But you've seen it all. They're just going to talk fast, and you're going to get blown away, and don't worry about it. Hang in there. You know everything you need to know. Now, here's the magic. By putting this triangle on an XY axis, you have found the ordered pair at that point where the triangle touches, okay, the circle. That ordered pair is radical 2 over 2, comma, radical 2 over 2. Because we went over X up Y, and that gave us that ordered pair. Okay, and we got that ordered pair because we put the triangle onto a unit circle, and we use the XY axes to help us graph that ordered pair. Okay, that holds for every 45, 45, 90 triangle that you can draw on this unit circle. For example, what if you draw an upside down triangle right here, but it's 45, 45, 90? Yep, I know you can't read, my pen's kind of fat. Well, as long as it's 45, 45, 90, we know that the hypotenuse is 1, okay, because it's a unit circle, the radius is 1. But we know that the side of this is the square root of 2 over 2, but its coordinate, well, okay, I'm going to write it this way. This is also square root of 2 over 2. This square root of 2 over 2 is the side of this triangle. This square root of 2 over 2 is the side of this triangle. But hang on, this coordinate is negative radical 2 over 2, comma, negative radical 2 over 2. Where did the negatives come from? Why are they negatives here when they weren't here?
The quadrant.
The quadrant, that's it. It's still the same damn triangle. It's got the same legs. It's got the same hypotenuse. We just drew it in a different quadrant. So it'll have the same numbers, just different positives and negatives. Okay? Now, we can go further. I'm going to erase my unit circle. Put a new one up. Okay. I'm not going to label it. I'm just going to put there. And what if I put a 30, 60, 90 triangle on my unit circle? Well, according to what I just did, the hypotenuse is 1, and that matches with the radius is 1. It always has to do that. But we figured out that opposite the 30 degrees, this was a half. And opposite the 60 degrees, this was the square root of 3 over 2. So in trigonometry, they're going to say this ordered pair is 1/2, comma, square root of 3 over 2. Simply because they wrote it, they drew that triangle on there. And if they happen to draw it into the third quadrant, then it's going to be the same numbers, 1/2, comma, square root of 3 over 2, except you're going to fudge an extra minuses in there because it's in the third quadrant. Okay, so if you understand the 30, 60, 90 triangles, and you can find all the missing sides of the special triangles, the 30, 60, 90, and the 45, 45, 90. If you can do that, if you understand the vocabulary of what's called a unit circle, okay, and you understand that this is its equation, and you kind of understand how I put the triangles inside the unit circle or on the unit circle, then you've got a big jump on everybody else who's trying to take trigonometry with you. Okay, if you can do that, and you can use the Pythagorean theorem, which is a squared plus b squared equals b squared equals the hypotenuse squared. Okay, I don't like c, I like at least hypotenuse. Okay, you're going to get through a whole bunch of trigonometry with just these facts right here. So that is why, one big reason why I wanted to talk about conics, because I wanted to talk about the circle, and why I was talking about those special triangles, okay, because I knew that in trigonometry, these two concepts are combined together. Okay, and they always scare students at the very beginning of trigonometry. And I'm hoping that this little bit of discussion will take some of the scare and some of the mystery out when you guys start trigonometry. Not all of it. Trig is weird. It's a whole different language, but that's it. All right. I don't expect you to understand everything I did. In fact, I don't expect you to understand half of what I did, but you should see the two concepts of a circle and triangles somehow are related to each other. And if you see that, I'm happy. Anybody got any questions? No? I mean, I don't know what you'd have questions about, but that was me trying to get you a heads up.
So each quadrant will only have two triangles in them, right?
Well, actually, it'll have three that we think of, because if you lay the 30, 60, 90 down on its side differently, this could be the square root of 3/2, 1/2. If you lay it, instead of having the 60 degree here at the origin, if you twist it so that's a 30 degree, that will flip your ordered pairs. But they'll always be square root of 3/2, 1/2. Square root of 3/2, 1/2 will always be associated in some way with a 30, 60, 90 triangle. Always. That will never change. Okay, or not?
Now I know how to order my pizza.
Huh? All right, you lost me, but okay. How would you order your pizza? Sliced up?
Yeah, 45, 45 or 36
Okay,
squares.
I'd like to see somebody do that. Okay, go ahead, try that and see what you get from Domino's, or maybe Little Caesars. They may like it better. Just one more thing I want to show you, and just so you don't get scared. Okay, back to the unit circle again. Let's say we put a 30 degree angle here. Well, they measure angles in degrees. That's how most of us have learned to measure an angle. We got 30 degrees, we've got 90 degrees, and we put a little square in there. We've got 45 degrees. We always talk about degree being how open something is. But there's another way to measure a degree, or excuse me, there's another way to measure an angle, and that's with something called radian. Okay, A radian measures the arc length. If you say, hey, I want to go up here a certain amount, it will make an angle. Or if you say I have an angle, it will make an arc length. An arc is a piece of the circumference of the circle. So they're going to introduce in trigonometry, they're going to say, okay, well, you learned all about degrees. Okay, those are easy. Now we're going to teach a different kind of way to describe an angle. It's called a radian. And a radian just says, oh, if I open up this arc on the circle, it creates a triangle, okay? And I can then find all the missing pieces. Okay, so they're gonna, I don't want to go into too much detail because I don't want to, number one, I don't want to teach you trig. You got enough trouble worried about Math 96 right now. But I do want to give you just a little bit of heads up. There is more than one way to describe an angle. You can either describe it in degrees or you could describe it in radians. A radian is an arc length, a piece of the circumference somehow, and they both make angles. And that's enough. If you, again, know half of what I was talking about, you'll do great at the beginning of trig. You really will. All right, now that I've thoroughly confused you, none of that, by the way, is on tomorrow night's test, and none of it is on the final exam, so don't worry. But I wanted to get that in there and show you kind of why we were learning all this crud. Did anybody happen to tune me out, ignore me, and find another question that they wanted to ask? No? Okay, you can do all of the problems on the practice thing. Nobody has any questions? Okay, you sure? Well, then, other than just answering your questions, that's all I wanted to do tonight. I wanted to talk about triangles and unit circles and stuff. I wanted to answer every question you had and just get you ready for tomorrow night to the best of everybody's ability. So if nobody has any questions, yeah, go ahead.
I have one. So it's a it was on the homework and I keep getting them wrong for some reason. It's a 30, 60, 90 triangle with the
Okay.
sides labeled ABC.
Okay,
And
where's
then
the third? Where's the 30?
The 30 is on the bottom.
Okay. All right. Who's A, who's B, who's C?
A is on the all the way to the left, B is on the bottom, and then C is the hypotenuse.
Okay, cool. All right.
And then it says suppose B equals 2, find A and C. And I don't know, but I keep getting them wrong.
Okay, all right. Good question. Definitely a question similar to this on tomorrow's exam. Definitely. Okay. So we'll put B as 2. Okay. You're thinking if this is 30, then this has to be 60. Okay. Of all the relationships in a 30, 60, 90 triangle, okay, somebody was A, somebody was 2A, and somebody was A times the square root of 3. Those are the sides. What side is 2? Which of these does 2 measure?
Negative 2a?
Oh, it's not negative. Okay, that's just a hyphen, a dash. Okay, all right. A is opposite the 30 degrees, always. So 30 degrees is the small side. Okay, 2A is opposite to 90 degrees, always. And so A radical 3 is opposite the 60-degree angle, always. That's the first thing you have to do is you have to analyze your triangle and say, the 2 is opposite the 60 degrees. So the 2 has to be the A radical 3. Because opposite 60 degrees is A radical 3. So 2 has to equal that. But I can use my algebra to solve for A. So if I divide both sides by radical 3, I get 2 over radical 3 equals A. Now, for all intents and purposes, you're done, except that we have this dumb rule that says you can't have a radical in the denominator. So you have to rationalize, multiply top and bottom by radical 3. So you get 2 radical 3 over, okay, well, that's square root of 9, but it simplifies to 3 equals A. Okay, what was A? A is the side opposite the 30-degree angle. So this is 2 radical 3 over 3. Okay. One of the things that might be confusing you a little bit, Carmen, is they're labeling things as A, B, and C. Okay. When we're using A, and A to mean something different. Okay. So there may be some confusion between the labeling, the letters that we're using. So question, Carmen, before I finish off, did you understand how 2 is equal to that formula?
Yes, so
Oh.
you pretty much changed B into A3 so that we could solve it, kind of.
Kind of, yes. The side that's opposite the 60 degrees has to equal this. The side that's opposite the 60 degrees has to equal this. So 2 was opposite the 60-degree angle. So 2 has to equal this.
So to solve C, it would be was it 2 equals 2A, right?
No,
Nope.
Okay.
Wait, no, that doesn't make sense.
so this side is opposite the 90-degree angle. It says opposite the 90-degree angle, I'm going to go 2 times the A side. So this is going to be 2 times 2 radical 3 over 3. So this is 4 radical 3 over 3. This is my angle. And this is the side opposite it. Okay, and just based upon your question, I don't think I did a very good job explaining it.
I get it, but I don't know how to word that I understand. So maybe I don't.
Okay. Do you want me to do a different one?
Yes. I have another one that has where B equals 9.
Down here is 9. Okay.
Yes.
All right. So let's go over here. Okay. Again, everything depends on the placement of the angles, the 30, the 60, the 90. Okay. So when you said this was 9, I'm hearing that the side opposite the 60-degree angle is 9. Is that correct?
Yes.
Okay. Forget the A and the B crap. That's just for mom, or that's just for the worksheet or whatever it was. Just the side opposite the 60-degree angle is worth 9. But according to this formula, the side opposite the 60-degree angle has to be that. So I can make an equation to say 9 equals a radical 3. Because remember, I need to find this number, and I need to find this number, and these require me to know what A is worth. Not A in the picture, but A in my formula. Okay, so if this is 9, I have this equation that pops up automatically because the side opposite the 60-degree angle has to equal this number, this formula. So I just wrote that down.
I understand now.
Okay.
And
Then,
it's finally clicked.
okay, good. Then the algebra we go through, we divide both sides by radical 3. So we get 9 over radical 3 is worth A. But then we go, crud, got to make it pretty. Radical 3, radical 3. So this is going to be 9 radical 3 over 3, because 3 times 3 is 9, square root of 9 is 3. But the whole stupid thing simplifies into 3 radical 3 is worth A. So question, where is A on this picture? Not on the worksheet. On this picture, where does that number go?
The opposite of the 30-degree angle.
Good. So this is 3 radical 3. Okay. Now, the last thing is the hypotenuse. Okay. The hypotenuse is opposite the 90-degree angle, and it's 2 times my A number. 2 times the A number. So this should be 2 times that should be 6 radical 3. Yes or no?
Yes, yes, thank you.
What
I don't know
about
why I
every?
just wasn't clicking.
No, it's if you haven't seen this before, it takes time and it's confusing. And the letters on the worksheet, was this from the worksheet or is this from mom?
This was from mom.
Okay. Yeah, the ABC on mom is confusing because we use the letters A appear as our variable for the formula. So it's easy to get confused between, oh, the A in the formula or the A in mom. Which one is it? That's why I always go to pictures. Okay, everyone, this kind of question where I give you a 30, 60, 90 triangle and give you one of the sides, I won't tell you which side, and ask you to find the other missing sides. Absolutely, that's a question tomorrow night. And I believe on the review worksheet, the practice worksheet, that's problems number 7, 8, and 9. Okay, so they're there, and I think my work is right. Anne's here, she can tell me I was wrong. Hey, Anne, we found somebody that we found an error. Lindsay found an error that both of us missed.
Yeah, I didn't see that for the first time. I just checked I checked on
Yeah.
the enter. And then
Yeah. I got like I said, I got my answers right. My work was wrong because I cheated. Okay. Anybody else? Any other questions on any of that, any of the worksheet, any of the mom? Let me put it this way, guys. Right now, I would stop doing mom and I would make sure that you could do this practice worksheet forwards and backwards, inside and out. And you really knew what you were doing. Okay, because this is the test for all intents and purposes, mostly. Okay, so you want to do well on the test. If you have time to finish, Mom, great. But do the worksheet. It's better. It's more important. Any questions? Okay. Are we got to stare at each other? I'm going to pause the. Oh. Okay. So number one says we have some rocket is shot into the air, and this is the formula: h of t equals negative 9 t squared plus 126 t plus 700. And there's meters and seconds and all kinds of crud. All right, so part A says what is the initial height? Okay, initial means when time is 0. Initial means at the beginning of whatever you're doing, at the beginning of the experiment, at the beginning of when the rocket is launched. So this is technically time equals 0. So you go h of 0, the height when time is 0 is negative 9 times 0 squared, whoops, plus 126 times 0 plus 700. So it technically equals 700. So how high was it at the time? I think it was 700 meters. Okay, 700 meters. Okay. That all right with everybody?
Yeah.
Okay. All right. Now, part B says what was its max height? Okay. Now think about it. This shape is a parabola. This shape is a parabola. It's a down parabola, as a matter of fact, because it's negative. So what this is telling me, without doing too much work, I'm starting at 700 meters high, must be on a mountaintop somewhere, okay? And I'm shooting it up in the air, and then it's going to come back down and hit the ground sometime. And the problem is saying, what is its max height? Well, the max height is at the vertex. That's what you need to know. When it talks about the maximum or the minimum, it doesn't matter. Maximum or minimum, it will always occur at the vertex. Now, this is a maximum because that's the highest it's going to go. All right. So what about at the vertex? Well, there's a formula you must know. It was negative b over 2a, comma, plug it in. Okay. So you take negative 126 over 2 times negative 9, comma, something. What's that? 18. Is that 8? Maybe should I look at my work?
7.
7? Okay, 7. Okay. Now, what I'm doing next, this is okay. This is my t value. Boom. T. I plug it in to find my height, h value. Okay. Keep in mind on this picture, what used to be our x-axis is now our time axis. The x-axis used to be is the time axis, and what used to be the y-axis is now the height axis. Okay, so if we plug it in, and if I didn't screw up, and if Ann caught me, I got 1141. Okay, so this is my height. Now, hang on. If you tell me this, you're going to get something wrong. If you just say, oh, 7 comma 1141, you're wrong. What was the question for part B? What was the question?
The
Anybody?
rocket's maximum height.
Right.
What is
So which one of these represents the height? This is the
Y
vertex.
value?
Yes, the Y value or the height value. This is the vertex. That's the algebra, but this isn't just algebra. This is a word problem. So you have to translate the algebra into meaningful words. So algebra says this, but what this says is the maximum height is 1141 meters, because if you read the problem, it talked about meters. I think it talked about meters. Yeah, being the unit. And parentheses at or after 7 seconds. Now, the reason I'm putting in parentheses is because that's actually not necessary. That's not what the question asked for. It said, what was the height? So the height was 1141 meters. That's all you had to answer. If you answered both of those, then I don't know what that means. So you have to make sure you answer the question.
okay? I guess I'm confused. How did you get the 1141?
Plugged in 7 into this mess.
Oh, thank you.
Question, Professor, if you flip everything to make the t squared positive, will you still get positive 114?
You can't flip everything until you make this equal to 0 or equal to a number. No, you won't. The reason you were allowed to flip everything was when there was a number over here. Because then you could multiply both sides by -1, or then you could move everything to the other side. Okay, but no, you can't flip it until you have a number over there.
Gotcha.
Okay.
Thank you.
Yeah. Okay, so that's part A, part B. And of course I wrote into the glare. Yay. Okay, part C, we did a little bit earlier, but I'll go through it quickly. Part C, when does it hit ground? Okay, hit the ground means H is worth 0, because when it hits the ground, okay, the height is 0 again. It started at 700 meters, wherever that is. It went up to its max, came back down, hit the ground, height is 0. So now we're going to solve this problem. 0 equals -9t squared plus 126t plus 700. Now, at this point, I cheated and just put everything into my calculator. But now, Vince, because you have numbers on both sides, now you can move everybody to the other side, or now you can decide to multiply by -1, or you could just ignore it, ignore everything I've said. But you plug this into the quad formula, which I'm not going to do right now. You can double check that. And I believe you get either t is -4.259, or you get t is, what did I get, 18.259. Okay. And so since t represents time, and at least at this point in our math, we don't know about negative time, okay? Or we're not going to worry about negative time. The only answer is that one. So after 18.259 seconds, or whatever it said to round to, this is time, so this must be seconds, and this is a definite reject. because of the negative. Is that okay? Who was asking that one? Naomi?
Yes,
Okay, are
thank
you okay?
you.
You're okay
I
with that?
am. Yes, I
Okay.
am. Thank you.
All right. And for everybody else, I did turn on the recording. Yes, absolutely guarantee there's a question right there. Guaranteed. Boom. With all of those parts. Maybe not the initial height, that was too simple, but definitely what's the vertex? Definitely when does it hit the ground? Maybe, when is its height 1,000 meters or something like that. So you do the same thing, you make it equal 1,000, and then you solve using the quad formula or whatever. But there it is. Anybody else?
When you say you cheated and put it in the calculator, are you doing that under the system solve? No,
Not system, polysolve.
it is under the polysolve. I see. I was just trying to compare your answer.
It's under the polysolve. Can you get it?
Okay, I'm gonna try it.
Okay. And if you're going to use the polysolve, then you may as well just use the initial one and not have to worry about, making it positive and, dealing with Foster's idiosyncrasies.
Right, flipping it over. Okay, I see it. Yeah, it is.
Okay.
Are we allowed to use that in the exam, or do we have to show the quad formula?
I think it says, excuse me, show me your quad formula setup, and then just use that to finish it off. So show me that you knew how to stick this in the quad formula, and then just go use that.
Oh, cool.
Do you mind if we go over question number 4?
Sure. I sat on my pen and broke it. Ouch. Okay. Can I erase this? Is anybody still copying this? Richard, you're taking a screenshot or anything?
I'm good.
I got it. Thank you.
Okay, cool. Everybody's got it? I can erase this?
Thank you.
All right.
I still get lost in my notebook and my screenshots though.
Well, how do you can't print them out. How do you put them in your notebook? Or how do you utilize it?
I just view them on the iPad.
Oh, isn't there a
For
note
reference.
taking? Isn't there a note taking feature on the iPad? So can you put it? Can you place it in your notes on the iPad? I don't know.
I suppose I can. I got to look into it.
I don't know. Okay. Whenever I have technical difficulties, I go ask my granddaughter. She's 9 years old. She knows everything. Okay. So, Carmen, anyone in particular?
Sorry, 4A.
Okay. All right. 4A, we have x plus 2 quantity squared plus y squared over 36 equals 1. Okay, a couple things before we get started. It looks to me like an ellipse. Okay, but it's missing some pieces. So this is x plus 2 quantity squared over 1 squared. Remember, you could always divide by 1 and you're not changing it. You're changing what it looks like, but you're not changing its value. This one, you can write it as y minus 0 squared over 6 squared equals 1. Again, you can always add or subtract 0 to something, add or subtract. It won't change the value, but it will change what it looked like. And then I took the 36 and just wrote it as 6 squared just because. So this is an ellipse. My center is -2, 0. My x radius is 1. My y radius is 6. Okay, where's my glare? Okay. So I go to -2, 0. Okay, my x radius is 1. Whoa. So that says go over 1. This is going to be -1, 0, or go backwards 1. This is going to be -3, 0. Scale is kind of screwy. Carmen, are you okay with number 1, how I got the x radius, and number 2, how I used the x radius?
Yes.
Okay. Everybody okay with my x radius? Where I got it magically, it just appeared. Okay. Santa Claus came. Okay. But then how did I use that x radius as 1? It's always measured from the center. So I went to the right one, to the left one. Now my y radius is 6. So if this is 1, should be like up here. So this is the point -2, 6. And this is the point -2, -6. So my y radius tells me how much I go up and down. Okay, from the center. Again, the center is the key. So then I just simply connect the dots, try to make it as smooth as I can. Okay, and there is my ellipse. And I said to label the center, which I did right there with a dot. And I said label news. News is north, east, south, west, whatever. The 4 corners of the ellipse or the circle. So Carmen,
Okay.
is that okay?
Yes, I was just kind of having trouble about how to get from what was shown to the formula where we can pull information out of it, but I understand now.
Okay. All right. So do you want me to do the rest of them or are you okay?
I'm okay.
Okay.
Can you do the rest of them, please?
Okay. You like 4B?
Yeah, 4B.
Okay. Didn't people that? Okay. 4B. 4B. So we talked about a shortcut. In fact, Anne brought it up yesterday. Okay. But at this point, I'm not, Anne and Lindsay brought it up yesterday. Okay. I'm not going to use the shortcut. Okay. Which conic shape is this? And how do you know that?
Sorry, I was on mute. It's a parabola.
Okay. Yeah. Go ahead. Keep going.
Parabola,
Okay. Why? How do you know that?
because there's only one variable that's squared.
Excellent. And again, what I see is basically if you strip away all the other crap, I see y equals x squared. Those are the key features of this parabola. So that tells me I know it's an up parabola. Okay, do you guys understand what I mean when I say just strip away all the extra crud, all the stuff that makes it fancy? This is y, this is x squared. So that's the basic parabola that we've been studying for a long time. Okay, so I know what it's going to look like already. So here I go. If that's the case, then what I'm going to do is move the 12 over. Okay, and notice it's in vertex form. Well, lots of things. First off, I know it's a parabola. Okay. And I know that my A value is +3, so it's going up for sure. And you won't be required to answer this, but remember, the bigger the A value, 3, 4, 5, the skinnier it gets. So this is going to be a pretty narrow parabola if I was to graph it. Or if you were going to go put this on Desmos or something like that, it'd be kind of narrow, kind of tall and skinny. All right, my vertex, I don't have to use that -b/2a. I can use, this is called standard form or vertex form. This is 5, -12. Recall the confusion was, if you're just pulling the information out of the parenthesis, quantity, x minus 5, then you take the opposite of what you see. You see a -5, you take a +5. But if you're just using the 12 out here, it's not in parentheses, so you just use what you see. That's a -12, so I use a -12. There was a way around it. Again, Ann and Lindsay talked about this, but I'm not going to go there right now. So what do I got? Oh, some other things. You're going to be asked to find the Y-intercept. You need to know that when you find in the Y-intercept, you're saying X is worth 0. You need to know that. On any math, trigonometry math, if somebody's going to math 116, okay, or whatever, and they're doing all kinds of stuff, or you're going on the pre-calculus, the minute they say find that Y-intercept, you say, aha, that means plug in X equals 0. Automatically. So if I want to find the Y-intercept, I have Y equals 3 times 0 minus 5, quantity squared, minus 12. Okay, doing some arithmetic. -5 squared is 25, 75, 62, I think. So I get Y equals 62. So excuse me, my Y-intercept is 0, 62. Is that all right with everybody? Okay.
Is it 63?
Yeah.
63, thank you. Apparently my batteries need recharging. 75.
We get
to
extra.
20.
We get
Credit?
extra when we correct you.
Yes, I'm taking notes. Everybody who's embarrassed me all semester long, I'm going to remember you. That was a threat, wasn't it?
You could always go back to your videos too.
I can. That's another good reason for it. Yes. I don't know if I'm ever going to have to use those videos again. If we're back on campus in the fall, what am I going to do with all those videos? I can't videotape myself in the classroom anymore. I tried that one semester. I had a student hold up my iPhone and tape me. And first off, I walk all around the classroom, so the student's trying to move my iPhone all around while I'm walking around. That came up with a really crappy picture. And then occasionally the student got real confused and would sometimes flip the phone over. So instead of video recording me, the student was video recording their face instead. So I didn't have really good results for putting things up into YouTube. So I don't know what I'm going to do in terms of getting a video up next semester. Things are going to be really weird.
You can just try a selfie stick, carry it around with you.
Yeah, I suppose that, no, I'm not gonna do that. No. Maybe I'll hire my granddaughter. Nah, she can't stay out that late. Okay. I don't know. That may be the thing to do. All right, then we want to find the X-intercepts. Again, that means Y is worth 0. That has to be instantaneous. You find the X-intercept, that means you set Y equals 0. So we have 0 equals 3 times X minus 5 squared minus 12. Now, a couple of things here. How you solve this is your business. Okay, if you want to FOIL this out and combine like terms and then use the quad formula, okay, at least set it up and then show me the quad and then go use your calculator, you can. But I'm going to suggest that you use this. You go, oh, look, if I move the 12 over, divide by 3, I still have room, square root both sides. Okay, let me see if I can sneak it in here. I'm going to have X minus 5 equals plus or minus 2. It's too small. Let's write it again. X minus 5 equals plus minus 2. A little bit better. Square root of 4 is 2, but when you square root a square, you got to remember that plus minus. So add the 5, X equals 5 plus minus 2. So what that says is my X-intercepts are either 7, 0, because remember Y was 0, or it's 3, 0. Okay, hang on. I hate to do this, bad teaching. I want to come back to this. I need to erase this problem, but question back here, I forgot to add, what's the domain and range of this question? Okay, so I want to answer that before I finish this problem. Okay, so take a second, think about the domain and range. I'll pause 1 minute and then we'll come back. Anybody want to take a shot at the domain on this ellipse?
Domain -3, 1
Yeah, bracket.
bracket.
Yeah, because
Dang
it
it.
can touch -3, it can touch -1. Domain, remember, is the X values. Okay, anybody different? Not saying Carmen's different. Oh, never mind. Never mind. Anybody want to try the range?
-6, +6.
Brackets. Yeah, don't forget the brackets, but you're right. Is that okay now with everybody? Does everybody understand where those answers came from and why they're correct?
Why is it a positive one?
Because I'm an idiot. -1. I believe Carmen said -1 and I just wrote it as +1. -3 to -1 are my X's. You're right, I'm wrong. Is that okay, domain, on that problem? Can I erase this one now? Okay.
Yes, thanks for the
Yes.
reminder.
Yeah. Yeah. I mean, that's on there. I forgot. Well, I knew I was going to do it on this other one. So, okay. So let's graph this sucker. All right. Vertex 5, -12. 5, -12. Okay, vertex. Okay. Y-intercept 0, 63. Okay. Please notice that my graph is absolutely inaccurate. it gives me enough information that I can understand what's happening. Okay, but that scale is totally wrong. If that's 12, that can't be 63 up. But it gives us an idea. That's why you label the ordered pairs there, so I can also read. Now, I'm going up and I'm very, very, very narrow. We talked about that. So it's coming down like this, going up like that. I know that this point here has to be 7, 0, because that's an X-intercept. And this point here has to be 3, 0. Because that's an X-intercept. Now, there's more I need to put on. Okay, I need to put the axis of symmetry. I need to talk about domain and range and all that junk. But that's 90% of this graph, of this problem. Parabolas have a lot of work. Okay, finding the vertex, finding the X-intercepts, finding the Y-intercepts. There's a lot of work. Therefore, there's a lot of points put into a parabola. Okay, so my work, my graph. Any questions about any of my parabola work or how I translated that work into some kind of graph over here? Okay, where's the axis of symmetry? Where does it go?
X
On the
equals
5.
5.
Through the 5. An axis is a line, like the x-axis is a line. So the axis goes through the vertex. Okay, the axis of symmetry is that its equation is x equals 5. That's its equation. Okay, and that's what it's going to say. You just can't say AOS equals 5. Okay, AOS is short for axis of symmetry. No, the axis of symmetry is the equation x equals 5. X equals 5. Okay, lastly, I need a domain and a range for this whole picture. Anybody want to take a shot at the domain?
Try domain, is it bracket 5? Wait, sorry, I was thinking about the range. Bracket 3 to 7.
Okay, let me show you. When you say bracket 3 to 7, okay, you're saying that the x values for the whole picture only
Never
go.
mind.
Okay. Remember, domain refers to the domain of the entire shape. Question, it doesn't show it up here, but what is the shape of this parabola? Well, we call it a U, but it keeps getting wider and wider and wider. Okay, so eventually we're going to use all of these x's, and eventually we're going to use all of these x's. Eventually we're going to use every x in creation. So the domain of this shape is either the fancy R for all real numbers, or you can say negative infinity comma positive infinity with parentheses. Either of those would be acceptable for the domain, because this U curve opens up wider and wider forever, so it covers every x. All right, what about the range? Anyone?
Bracket -12, comma, infinity, parentheses.
Yep. Range. Bracket -12, comma, infinity, parenthesis. Because the range is the y values, the lowest y value is negative 12, and then the y's just keep going on forever, up and up and up. Yay, nay? Yes or no, everybody?
Yay.
Yay.
Yay. Yay. Yeah, I can tell your enthusiasm is just overwhelming. Yay. All right. We have 4C to do. I'm probably going to need to erase this. So I'll give you a second to catch up, second take a picture, then I'll erase and do 4C. If anybody has any questions on this, I'll be happy to answer them.
I have a quick question, Larry.
Sure.
Move on to C. Is this
Mhm.
to say that as soon as I see a fraction, I can determine that the conic shape is either ellipse or hyperbola? Is it safe to do that kind of determination just by looking at the equation? And if I
Hmm.
see the fraction, I can say that's either ellipse or hyperbola.
Well, no, I'm not sure that's safe. You have to also look at the powers. Well, okay. Either ellipse or hyperbola. Yeah, you can say that. Yes.
Okay. Just by
Well,
looking at
it could be a hyperbola too.
yes.
We haven't studied hyperbolas. And by the way, guys, other than on MOM, there's going to be no question about a hyperbola. So that's another reason to not keep doing your homework, study this worksheet. But and to answer your question, yeah, if there's a fraction, it's an ellipse, hyperbola, or parabola. And since we're not doing hyperbolas, it's an ellipse or a parabola. You're right.
Okay.
Okay.
Cool.
Can I erase this, everyone? Okay. I keep waiting for someone to yell. I did tell you what my calculus classes used to do to me, didn't I? Every day they select a different person. And so I'd say, can I erase the board? You know, I work on the board. And I'd start to erase and someone would yell, no, wait, stop. And it was always a different person, so I couldn't get mad at anybody. And they worked out this elaborate way of just, well, basically they wanted to bug the hell out of me. So every time I said, can I erase? Nobody said anything. So I would start to erase, and then they all start to yell at me one at a time. Love those kids. All right, 4C. We have this x equals y squared minus 5. Oops. Oops. What shape is this?
Parabola.
Okay, but it's a parabola.
Sideways? Sideways.
Good. Parabola, again, ignoring the 5, is x equals y squared. So it's going this way. Sideways parabola, x equals the square, it's going to go sideways. So I know that. Okay. What do I want to do? Well, it's going sideways. So, all right. I see this as this. Remember, we talked a little bit earlier about how you can always add or subtract, or excuse me, yeah, add or subtract zeros because they won't change the problem. They'll change what it looks like, but not what it's worth. By sneaking the 0 in here, I know my vertex is -5, 0. Now, hang on. Remember, the vertex is always the x, y. So the 0 was with the y, and the -5 was left over to be with the x. When you're graphing on the xy axis, an ordered pair is always represented as x, y. So even though it looks like y is first in the formula, it has to be last in the ordered pair. So you need to be careful of those little details. Okay, I know it's going to the right. I know my A value is 1. Okay, if you wish, you don't have to write that down. A is 1, so it's whatever normal is. It's not too wide, it's not too narrow, it's normal. Okay. What else? Oh, here we go. I want to find the y-intercept. So that means x is worth 0. So I write 0 equals y minus 0 squared minus 5. Bring the 5 over. 5 equals y squared. Square root both sides. Oops. Square root. So I get plus or minus the square root of 5 equals y. Or that's y-intercept. Means x equals 0. Glare. Okay. X-intercept means y is worth 0. So I write x equals 0 squared minus 5, which means x equals -5. So my ordered pair is -5, 0. Now, I'm not sure why, but I started talking really fast and writing really fast. So I'll slow down and let you guys catch up and let you guys also ask questions. I found the vertex, had to worry about making sure my x and y's matched the ordered pair. I found the y-intercept by setting x equals 0 and solving, or the x-intercept by setting y equals 0 and solving. So I'll be quiet for a second while you guys either finish copying or ask questions. I'm not done by a long shot. Okay, I'm going to start to graph it. Any questions about any of my steps or any of my work to this point before I start to graph? Okay, here we go. Then let's see. There's my x-axis. My vertex is -5, 0. The -5, 0. Cool. Now, wait a minute. How can my x-intercept be the same as my vertex? How is that possible? Or is it?
Because it crosses the X plane.
Yeah, that's it. The vertex happens to be where it's crossing the x-axis also. Okay, the graph is, yeah, the graph is going to look something like that. So in this case, the vertex is the x-intercept. Usually we have something like this, where the vertex is here, we have an x-intercept here, and then we have y-intercept someplace else. But this just happens to be where the vertex and the x-intercept just happen to be the same point. Okay. So this is 0, radical 5, whatever that is. It's like 2.5, good enough. Actually, it's 2.1 or 2.2, but that doesn't matter. This is 0, negative radical 5. I had 2 y-intercepts. One was positive, one was negative. I can see on my graph, I have a positive y-intercept and I have a negative y-intercept. So I just put the positive one up here and the negative one down there, and I'm done. Okay, and put little arrowheads on because it goes forever. Okay, the axis of symmetry is a little bit weird. It's hard to see because it's on the x-axis. Okay, it's actually y equals 0. This time, notice it's a horizontal line. Horizontal lines graph are labeled as y equals 0. The vertical line was x equals something. But because it's horizontal, it's y equals that number. Happens to be the x-axis. And lastly, we need to come up with a domain and a range. So this time, the domain, okay, starts at -5 and goes forever that way. So -5, comma, infinity. -5 is my lowest or smallest x, and then it goes positive that way forever for all my x's. My range, okay. Again, the concept of a parabola, this shape opens up wider and wider and wider the further out it goes. So eventually all of these y values are going to be used. Everything's going to be used. So in this case, the range is either the fancy r or -infinity to +infinity. Fancy r. And that's it for 4C. Okay. And that was Carmen's question. So he's done for the night. No more questions for Carmen. Actually, that wasn't Carmen. He only asked for one of them. So I can't pick on him. Damn. Okay. Anybody got any questions? Any other questions on what I've done on the board or what's on the worksheet? Or maybe you got some mom questions. Like, why do mothers try to make you feel guilty? I can't answer that. I don't know. Any questions at all? None? Are we done for the night?
I have,
Right.
but I want to save it for.
Okay. Where were you last night? We did number 2 last night.
I went on your normal Zoom link and at like 6:30, but I found out in the chat that it was Anne's that we started off with, and then we jumped over to yours.
Didn't you get any of my emails or didn't you get any announcements?
No, I did not, which is weird because I almost always get your emails. So,
Huh. Did my announcement come up to everybody? I put an announcement in Canvas. Did that hit everybody?
I seen it.
Okay.
let me look real quick.
So what we're establishing here is that Carmen's an airhead.
We
Okay.
already know this.
Oh. Well, I just wanted to make it really clear. Okay, I'm setting myself up for
Been a
Great
long
fun.
semester.
yeah, yeah. One more week. Hold on. Hold on, everybody. Just one more week. Okay. Actually, Cinco de Mayo comes about 3 weeks too early. We need Cinco de Mayo to be after the semester. Okay, so real quick, midpoint. Okay, is the average, so it's 7 plus -7/2, comma 4 plus 9/2. So the midpoint is simply the average. That's it. Okay, so whatever that works out to be, I think this is 0 and this is 6.5. So that would be the midpoint of that segment, whatever it looks like. Okay. The length, which is B, there's LENGTH. Is that right? GHT, whatever, GTH. Okay. Two ways to find it. Anne was using a variation of Pythagoras. I noticed that yesterday, which is fine because I taught it two different ways. If we do it that way, this is, it doesn't matter. Yes, it does. We'll graph it. So if we go 7, 4, it's like here's 7, 4, and here's negative 7, 9, something like that. So if we want how long is that, one way to do it is to create a triangle and say, oh, this side that went from negative 7 to positive 7 is 14. And this side that goes from 4 to 9 is 5. When you're going sideways, you're measuring the x values. So the x values went from negative 7 to positive 7. So that's a total of 14. The y values went from 4 to 9. So that's a total of 5. So when you set this up, then the distance is the Pythagoras, which is 5 squared plus 14 squared equals d squared. And I'm assuming you can go from there. And this is one of the ones where I made a mistake and caught it. The new answer, it turned out to be what? The square root of 221? Is that right?
Yep.
I think. Yeah, so, and whatever that is. So Carmen, are you okay?
Yes.
Okay. Slope of the segment. Slope. Remember, that's y sub 2 minus y sub 1. Whoops, come on, Foster, right? Neat. Over x sub 2 minus x sub 1. So this would be like 9 minus 4. That would be y sub 2 minus y sub 1. X sub 2 would be negative 7 minus 7. So that turns out to be 5 over negative 14. That's the slope. And that's back from chapter 2, I think. And then finally, the equation of this line. Okay, the equation of the line, the way I taught it, not the way everybody has learned. There are sometimes more efficient ways, but the way I taught it was to plug everybody into that, solve for the b value, okay, and then see what happens. So I'm going to plug this point and this slope into that equation. So I'm going to say 4 equals negative 5/14 times 7 plus b. So I have the point 7, 4. I have the slope 5 over negative 14. I plugged all of those in. B is unknowns, but I can solve for that. So that becomes 4 equals negative 5 over 2. I think that's 13 over 2 equals B. I think that's right. I'm doing a lot of math in my head. 5 over 2, 2.5, 6.5. I think I'm right. I suppose I should look at my paper, but.
Yes, you're right.
Okay, I'm right. Okay. So because that's the B value, now I have everything I need for this equation. I say it's y equals negative 5/14 x plus 13 halves. Okay, and that was the equation. That was 13 over 2. Again, I've seen people use different formulas. I taught it this way using this formula, but there are other ways that other instructors teach it. But the bottom line is that's the answer. No matter how you start it, that's the answer. Okay, so Carmen,
Makes
That's
sense
it?
to me.
okay.
Yes.
Is there anything I haven't done? I've done 1, I've done 2. We did 3 yesterday. We just did 4 tonight. And 5 and 6. And 9. And spent quite a bit of time yesterday doing 10. So, and 10 has been corrected on my answer sheet. All right. Anyone else? I'm going to